Today we're going to talk about the N3300 load family of modules and how to use the analog monitor and programming connector signals located on the rear terminals. And labeled are the analog programming signal lines, external COM and external programming, and the analog monitor signals. You have analog monitor common, shown as ACOM, voltage monitor and current monitor signals, both VMON and IMON respectively. For the analog monitor signals, the current monitor signal is measured between IMON and ACOM. The voltage monitor signal is measured between VMON and ACOM. The monitor signals are between 0 to 10 volts and represent 0 to full scale input. ACOM is referenced to the minus input terminal of the load, so care must be used. If the minus input terminal is at plus 20 volts, so is the ACOM pin. If ACOM is grounded, this means there will be current flowing from the minus input terminal through the ACOM pin and can do damage internal to the load. The analog programming signal is applied between the external prog and the external COM pin. The analog programming signal is also between 0 to 10 volts and represents 0 to full scale depending upon the mode you're in. The analog programming signal is also a differential signal. The programming voltage controls whatever mode the load is in. So if you are in CC mode, then the programming voltage controls the input current. If the load is in CV mode, then the programming voltage controls the input voltage. Here's an example of scaling for the analog monitor signal using an N3300A load module, which is 60 volts at 120 amps full scale. The load would output 10 volts from the IMON to ACOM terminals when 120 amps is being drawn by the load. To scale this, we would set IMON is equal to 120 amps divided by 10 volts, which reduced equals 12 amps per volt. So all you need to do is multiply the voltage measured from the IMON terminal to ACOM by 12 amps per volt to get the input current. For the VMON terminals, the load would output 10 volts from VMON to ACOM when 60 volts is on the input of the load, and the scaling for VMON would equal 60 volts per 10 volts. This would reduce to 6 volts per volt, so you would multiply the voltage measured from the VMON terminal to ACOM by 6 volts per volt to get the voltage on the input of the load. For the analog programming scaling, here's an example for the N3300A, 60 volt 120 amp load module in CC mode. Since the load is in CC mode, the analog programming signal controls the current drawn by the load. So this means the scaling for the external programming port is 120 amps per 10 volts is equal to 12 amps per volt. So all you need to do is divide the desired current by 12 amps per volt to determine the required programming voltage to input to the external programming port in order to get the load to draw the desired current. If the desired current was 15 amps, you would divide 15 amps by 12 amps per volt, and this would yield 1.25 volts. If this voltage is input into the analog programming port, then the load will be set to draw 15 amps. I hope this has been helpful in showing how to use the monitor and programming ports located on the rear terminals of the electronic load family.